Air refrigeration cycle working on Columan cycle. It is also called as reverse Breton cycle or reverse Joule cycle. The diagram is given already in the last class. Once again I'll write. I'll write the marking part. You tell me what is this. What is 1 to 2? What is 1 to 2? You ಮಾತಾಡಬೇಕು. What is 1 to 2?
Adiabatic compression.
Adiabatic compression, yes, correct. And what is 2 to 3? This is cooler. You tell me, normally this is heat removal process by the condenser. Heat removal process by the condenser, that is QR. And what is 3 to 4?
Adiabatic expansion.
Adiabatic expansion. Adiabatic expansion by turbine. And again from 4 to 1, QA, heat absorption. That is called as evaporator. This is called as evaporator. And we are supplying the work. We are supplying the work from compressor. You have to remember these points. This is adiabatic compression. This is adiabatic expansion by turbine. This is constant pressure heat removal process, and this constant pressure heat absorption process. And this is, we are supplying the work from the compressor, that is shaft work. And this is a normal flow diagram. This is flow diagram. And the next one is PV diagram. PV diagram. Because these two are constant pressures. This line, this and the evaporator and cooler part is constant pressure lines. So these two are the constant pressure lines. This is 1, 2, 3 and 4. Okay, now you tell me what is 1 to 2? 1 to 2 compression, 2 to 3, this is QR and this is QA, this is adiabatic compression, and this is adiabatic expansion, and this is constant pressure heat removal process from the condenser. Constant heat removal process from the condenser, and 4 to 1 is constant heat absorption process by the evaporator, that is cold chamber. Meanwhile, I can write TS diagram. You write all these three. TS diagram. What is the meaning of T and S? What is the meaning of T and S?
Temperature and entropy.
Temperature and entropy diagram. So whatever the constant lines in the PV diagram, 3 and 2 and 4 and 1, this comes as vertical lines in the TS diagram. You can remember this one because we have so many TS diagrams based on the PV diagram. The PV diagram we can write 2 to 3 is constant pressure heat removal, and 4 to 1 or 1 to 4 is constant heat absorption. Whatever the pressure lines in, I mean to say, constant pressure lines is in vertical lines. Okay, and remaining two, sorry, 1 minute. The 1 to 2 adiabatic compression and adiabatic expansion is in the curved lines in vertical lines, the straight lines in horizontal lines. You can see here 1 to 2 is curved line. Again 3 to 4 is curved line. The 3 to 4 and 1 to 2 is comes as vertical lines, constant volume lines. The remaining like curved lines. You should remember these things. Now process 1 to 2. Process 1 to 2. Adiabatic compression. Adiabatic compression. ಬರ್ಕೊಂಡ್ರಲ್ಲ 3 diagrams na, it's complete, right? Yes or no?
Yes, sir.
Now this 3 diagrams, after completion of this one, I'll explain the process. The process 1 to 2 is adiabatic compression. The compression is takes place in the compressor. Understand? It is driven by a shaft. Okay, we are supplying the work. You should remember this is external aid of work we are supplying because refrigeration system. So the word refrigeration comes means I am supplying the work from the compressor. For the compressor, we want refrigerant vapor. Where exactly it's coming from? It is coming from the evaporator. That's what the warm air having the evaporator enters the compressor at condition 1. So whether it may be air or refrigerant in the form of vapors, it is entering into the compressor. So you should not contain any moisture content, whatever the refrigerant is coming from the evaporator. Okay, for that one we have one device called as accumulator here, but we are not showing here. The accumulator work is to remove the moisture content of the evaporator. The moisture content coming from the evaporator is removed by the accumulator and is transferring to the compressor. What is the use of this compressor? It is compressing into low pressure into high pressure. When we are pressurizing, the temperature part is going to definitely increases, and with the high pressure and high temperature it goes to the condenser. Okay, that is the meaning of the adiabatic compression. Now process 1 to 2, work done by the compressor, work done by the compressor, gamma divided by gamma minus 1 T2 V2 minus T1 V1. Work done by the compressor is equal to gamma divided by gamma minus 1 P2 V2 minus T1 V1. You can write PV is equal to MRT. PV is equal to MRT. I'll write this is gamma divided by gamma minus 1 M into R to T2 minus T1. Why this is T2 minus T1? You can see here in the TS diagram, T2 is more. You can find out here T2 is more compared to T1. This is T2 by T1. Okay, T2 by T1. So only this is entire because this is PV is equal to MRT. PV is equal to MRT. You can write this PV is equal to MRT. I will write this is in form of MRT2 MRT1. Then common factor in MR na T2 minus T1. This is taken. I have taken directly. You can understand, right? Any doubt in this part? Where exactly PV I am substituting MRT. Okay. If it is P2 V2 means this is T2 because M and R is constants. And P, where is exactly P and V1? I can take T1. This is the T1 I have taken. MR constant. Both MRs I have taken as common factor outside. T2 minus T1. This entire equation in terms of pressure I can convert in terms of temperature. This is the work done by the compressor in adiabatic compression in the first stage. Okay. The next one. Process 2 to 3 constant pressure heat rejection process. I'll write here. Process 2 to 3. What is process 2 to 3? Constant pressure heat rejection. Pressure heat rejection by the cooler or condenser. Is ತಗೊಂಡಿದ್ದೀರಲ್ಲ ಬರ್ಕೊಂಡಿದ್ದೀರಾ? What is the use of this condenser here? What is the meaning of the condenser? ಮಾತಾಡಬೇಕು. Yes or no, whether you know or not, you have to tell me. Condenser ಏನು ಮಾಡ್ತದಪ್ಪ ಕಾರ್ತಿಕ್? What is the use of the condenser? Matadi, whether you know or not. What is Amsa? Lavya, tell me what is the use of the compressor? Sorry, condenser. Condenser ಏನಂತ ಗೊತ್ತಿಲ್ಲ ಅಂದ್ರೆ ATD ಮಾಡೋದೇ ವೇಸ್ಟ್ ಇದನ್ನ.
It cools, sir. It cools the air.
The process of
cooling.
ಕೇಳಿಸ್ತಾ ಇಲ್ಲಪ್ಪ, ಏನೋ ವಾಯ್ಸ್ ಬ್ರೇಕ್ ಆಗ್ತಿದೆ ನಿಮ್ದು. ನನ್ನ ವಾಯ್ಸ್ ಕೇಳಿಸ್ತಿದೆ ಹೋಗ್ಲಿ?
Yes sir, cool down ಮಾಡುತ್ತೆ sir.
Yeah, how will you define the condenser? What is the condenser working process? For example, this is the condenser.
Heat exchanging, sir.
Is a type of heat exchanger. Now there is a 2 layers here. Okay, in this one I am transferring the refrigerant. This is a passage for refrigerant, and now this is circulation of water. This is water in and water out. This is the type of heat exchanger. If I am circulating the water, definitely whatever the hot refrigerant with high pressure is flowing through condenser, definitely drops down. It drops down the temperature. And one more thing you have to remember, the refrigerant and absorbent is not mixing each other. The water ಮತ್ತು refrigerant mix ಆಗಲ್ಲ. So whatever the heat carrying by the refrigerant, it is absorbed by the water. That is the meaning of the condenser. Now I can write heat rejected QR equals mCp T2 minus T1, because this has happened here. Heat rejection. Sorry, T2 minus T3. T2 minus T3, because heat rejection takes place here only. Understand? Q mCp T2 minus T3, that is heat rejection process. T2 minus T3, which is higher temperature. You can see here. TV diagram all indicates T2 is greater than T3. So only T2 first and T3 later. Any doubt here?
No, sir.
The next part. The next part.